Okay, so we want to use the intermediate value theorem to estimate zeros, a zero, and you know it's going to have two, but when I give you a general function, it's not going to be this simple, okay? And you're not going to know where the zeros are. If I give you a fourth degree polynomial, you're not going to know where the zeros are. Okay, you're not going to be able to find them by the quadratic formula. You're not going to be able to factor that thing, and you probably don't want to anyway. So you got to kind of explore a little bit. So just common sense. What's a number that makes this polynomial positive? Well, what are easy numbers to put into this polynomial? What's the easiest possible number to value a polynomial for? Zero. Put in zero, and the only thing got left is that number there. Got to know that. Okay? So let's see. Okay, so we know the function is negative at -6, right? Okay? Okay, well, we've got to find a number where it's negative and a number where it's positive, because to go from negative to positive, it has to go through zero, and that gives us an interval, and we know zero's in that interval, right? Okay? So, so we're going to find an x that makes f of x positive, okay? Well, what are you going to try next? What's maybe the next easiest number to evaluate a polynomial for? I know everybody's thinking 17 plus pi. That's the one you want to use, right? If I told you, pick a number and evaluate that polynomial for the number, what number would you pick? If you'd pick zero. If you have any good sense, you'd pick zero if you're in a hurry. If you want to show off, go ahead and pick 17 plus pi. Okay? But if you're in a hurry, what's the next number you would try? I'm not going to drag it out of you. 1. If you got 1, then you just add up this number, and this number, right? If you got -1, because we have to use -1 a lot of times, okay, then this one's going to be negative and this one's going to be positive. It's really easy to do this. F of 1 is, well, 4 plus 5 is 11 minus 6, it's 5. Okay? So we know there's a 0 between 0 and 1. Okay? It's negative at 0, it's positive at 1. It means if you drew a picture of it, here's -6, this is 1, this is the 0.15. It's a polynomial, so it's continuous. It doesn't have any breaks. If it was a rational function, it could have an asymptote and you don't know what's going on. Okay? You can't guarantee there's a 0 between the 2 points. Okay? Because it could have asymptotes. This could have a negative asymptote here and a positive asymptote here, and there wouldn't be a 0 in here. Okay? Okay, so where in the interval? Well, split the interval in half and see. Then go back and look at the video on intermediate value theorem. Okay? Okay, when x is 1/2, y equals f of 1/2. Okay? Equals well, 4 times 1/2 squared plus 5 times 1/2 minus 6. That's 4 times 1/4 plus 5 times 1/2 minus 6, which is 4/4 plus 5/2 minus 6. Okay? Well, 5/2 is 2 1/2. 4/4 is 1. If you add 2 1/2 to 1, you get 3 1/2. And you don't even really have to add them. If you just understand numbers a little bit, you know that these numbers are too small. Well, you know that these numbers are going to add up to something less than 6. So when you subtract 6, you're going to get a negative, right? Now you can go ahead and finish the calculation. You're not going to have a calculator. You can have to do little fractions, but it's not going to be that bad. Okay? So now, what the common sense of it simply is that, okay, well, we've got this interval from 0 to 1. I'm going to draw it a little bigger. Okay? Function's negative here, positive here, so there's a 0 in the interval. Now we've just figured out that if we cut this interval in half, at 1/2 here, we've realized that it's negative here. So we've narrowed down where the 0 is. Where's the 0 have to be between? What does the 0 have to be between? Well, you got to have a 0 if it goes from negative to positive, right? Okay? So we've got an interval here. Does it have a 0 in this interval? Oh, it might. Quadratics we can pretty well determine it probably doesn't. But it might for any old function, but we can't guarantee it, right? It's not guaranteed. I mean, it could go up here and back down and then go up again, okay? It might have a 0 here. We can't guarantee it. We can guarantee there's a 0 here because it's a continuous function that goes from negative to positive on this interval. Okay? So it goes negative, positive in the interval 1/2 to 1. Okay? Well, how are we going to narrow it down a little further? We're going to split that interval. Now we could split it at 3/4, but it might be easier to do the arithmetic with just decimal numbers. Okay? You know, down to 10. So, for example, if I ask you to estimate within 1/4, which I did on the problem here, where the 0 is, well, I'm going to say let's cut this interval at 0.7. okay? Normally you'd think cutting it in half, but if you look at the numbers here, this number is going to be, you know, just 2 or 3, okay? -2 or -3, and you're going all the way up to 5 here. So it's like -3 here, 5 here. You think that the 0 is probably going to be closer to this one than this one. So we're going to cut it at 0.7, which is closer to this than it is to this. Closer to the 1/2 than it is to 1. Because we kind of think the 0 is going to be closer to the 1/2 than it is to 1. We think it's going to be in here. And once we determine that it is in here, then we have narrowed it down to an interval of 1/4. We get a pretty good idea of where the 0 is. So, f of 0.7 is 4 times 0.7 squared plus 5 times 0.7 minus 6, which is 4 times 0.49 plus 0.35 minus 6. Looks like it's still going to be negative. Looks like I guessed wrong. Okay? That's going to be 1.96. That's not 0.35. Gosh, do your arithmetic right. What's the matter with you people? Okay? $1.96 plus 3.5 minus 6. It's still negative, but close to 0. Okay? And I really kind of thought it was going to be in that interval. Okay? So if I can be that stupid, you're welcome to be too. Okay? It's not that bad. Okay, so now I would say that's so close to being 0, that's only like -0.5. Okay? In the next tenth, it's just got to go to positive. I would bet on it, but I wouldn't bet the farm. Okay? So to be safe, I'm going to say, okay, we're going to go over here to 0.9. Okay, well, we conclude the 0 is not in the interval 0.5, 0.7. The interval isn't small enough. Still too big. So at this interval at 0.9. F of 0.9 equals 4 times 0.9 squared plus 5 times 0.9 minus 6, which is 4 times 0.81 plus 4.5 minus 6. 4.5 minus 6 is 1.5. 4 times 0.81 is clearly bigger than 1.5. Don't even have to, okay. So you can finish the calculation. And if you're not sure, you probably want to. So positive. So it goes negative, positive in the interval from 0.7 to 0.9. That's an interval less than a quarter, right? So we know there's a 0 between 0.7 and 0.9. If you want to find it closer, check out 0.8. Want to get it closer, we're going to have to go to smaller numbers, okay? And I'm not going to ask you to do that. I just want to see something you can do in 2 or 3 steps. I want to see that you understand the process, okay? Because numerical mathematics is really important stuff. Intermediate value theorem is important.